To install BakeMatcher, you want to go up to this Edit tab right here and go into the Preferences menu. Once you're in here, you want to go to the Add-on button here. And once you're in here, you want to go to the Install button there. Now, you'll want to navigate to the location that you've downloaded the BakeMatcher zip file, and you want to either double-click this, or you can select it and hit the Install Add-on button. Once that's installed, it should automatically search for it here, and you'll see the add-on pop up here. If you open this arrow, drop-down arrow here, you'll see there's some additional info in here, and if you ever want to uninstall the add-on, there's a remove button right here. So to enable the add-on, simply click the checkbox, and you'll see it pop up over here. If you don't see this menu over here, it is the N panel, so you enable this by hitting N. Okay, so you should have this BakeMatcher panel over here, and then the add-on is installed. One final thing, you want to make sure that you save your preferences over here, or you can auto-save preferences either way. I like to manually save mine. But yeah, that's it. Now you've installed the add-on. Alright, so to demonstrate BakeMatcher and to go over some of the features, I'm going to create a few objects here to demonstrate with. I'll create a cube, and I will turn this into our high poly example by adding a bevel modifier just to give it some supporting loops. And I'll add a subdivision surface modifier, and I'll shade it smooth. Now we've got this nice high poly cube here. Before we get too far ahead of ourselves, I will create some collections to organize these into. I'll name this one high for our high poly objects. I'll name this one low for low poly objects. And to create our low poly that we'll demonstrate on, I'll go ahead and duplicate this one. I'll delete the modifiers, create it flat, and move it into the low poly collection, like so. I also want to demonstrate how to set up floating geometry or floaters. And to do that, I'll just hide the low poly collection here, get our high poly here, and I will set the cursor to our face because we want our floating geometry to be on the side of the object. I'll create a UV sphere, like so. I will shrink it down, and I'll go ahead and go to the side view here, and I will delete the one half of it here, just so that we have our, like a rivet or something, and I can go ahead and even scale it like that. I have like this rivet type object here on the side, and I'll shade it smooth, add a subdiv, like one level of it, or yeah, one level should be fine. And then we have our rivet, and this can be a floating geometry object. And to set that as floating geometry, I want to put it in the high poly collection here, and I'll just go ahead and do Control P, and I'll set it to be the parent. So now this rivet object here is parented to our high poly cube, and that will be a good example here. So now we have our setup here for object matching, but really BakeMatcher is about a lot of different sets of objects being matched together. This won't do it justice to just show one here. So I'm going to go ahead and duplicate a bunch of these around, just make a whole bunch of them all over the place, get all different locations covered, anywhere they might be. We'll get a huge list of different objects and all of that. Okay, that should be good enough. So now we've got a whole bunch of objects in here. And you can see pretty quickly, if you're not naming your objects manually, as you create them or whatever, this can get out of hand very fast. And, trying to rename these to match now, if you're going to set them up for, bake by mesh name, can be pretty overwhelming. So I'll just go through now some of the features and how you will start setting this up for, matching. And this is going to be a very easy use case. I'll go over a more complicated real world scenario after this, but for now, yeah, this will just give you the basics, just a basic understanding of how all this works. So I will select my low poly collection. You can select all these manually if you want, but there's a built-in selection button here for collections that makes things easier, and it allows you to even select down the hierarchy, like to your high poly parented objects if you need to. So I'll just use this. Select the whole low poly, all the low poly objects, the whole low poly collection, and I'll go ahead and set this as my low poly. And this will name everything accordingly. It will number it all, give it the standard naming convention that you set here. You can change this to whatever you want, but I just like object, and that's the default. And so once all these are low poly, the rest of them are set to be matched. And I'm just going to go ahead and start with bounds mode to demonstrate. I'm going to hit the match bake objects based on all our visible objects. You can do selected, but here in this case, I want all of these objects. So I'm just going to do visible, and I'm going to go ahead and hit match. And you'll see very quickly on the left side here, we've got all these objects here in this readout that are matched, and there are no conflicts, no unmatched objects. Everything works as it should. So you'll see here, it even accounted for our floating geometry. And so this, based on Blender's naming convention with the 0.001, the indexing, this will bake also to this low poly cube. Since it holds the same name, it's just indexed differently. So this will bake to this low poly even if you export it outside of Blender to Substance Painter. This will bake with the high poly on this, and you can even move it to like that. But yeah, that'll bake properly. So all these objects have been matched, but how exactly are they matched? So I'm just gonna give you just a quick understanding here of bounds mode. So, with bounds mode, the way that objects are matched together is it takes a bounding box calculation. It just takes the bounding box of whatever object you have, and it does it based on global mesh data. So it doesn't matter what the transform of any of your objects are, it will do it based on global space, where the vertices are and all of that. So you don't have to worry about any of your transforms for this. It will compare the bounding box of all the different objects, and more specifically, it will compare the corners. So it will compare each and every corner, and all the corners of the bounding box need to match based on this distance threshold here. It will compare the distances for each of the corners, and all of them, all 8 of them, need to match. If one is wrong, it will not get matched. So it's very accurate. As long as this distance value is tuned properly. This here is optimized for the default Blender scale. So like when you create a cube and it's about yay big, right? About that scale there. That's what it's optimized for. If you work at a larger scale, like if you're working on some kind of game project that uses a larger scale, or if you're working at a smaller scale for some reason, you might want to adjust this number to get more optimal distance. But by default, it's 0.1. So and that'll go by like the default Blender scale of things. If I create a sphere here, and I give it a size of about 0.1 for the radius, this is the size that we're talking about. So it'll be like that per se, kind of. So this is kind of the distance, right? So if we look inside of this, you'll see that as long as it's within this range here, it will catch it. Right? So if it's outside of that, it won't match. So that's just kind of how you can kind of visualize it in a quick and easy way. It's based on the like a 0.1 distance radius. So like pretty much exactly that amount. So if you ever want to like tune this number and kind of figure out what size is necessary for the scale that you work at, you can try making a sphere, because it's really a distance. It's all directions. So you want to like a sphere to see what the distance should be for that. Okay, so that's kind of how bounds works in a nutshell. Hopefully you can understand that. Origin mode is essentially the same thing, but with origin, the origin point. Instead of the corners of the bounding box checking all 8 of them, it just checks the origin point right there. With the objects. And all of these have the same origin point, so they're all going to match up the same way. So this can be more flexible if you're running into issues, because you can actually just manually change the origin point. And there are a bunch of origin tools down here that help you do that easier. There's an origin to active function, a reset origin. These make your life a whole lot easier for working with origin mode, but bounds is meant to be sort of the smart mode. It's more like fully automatic, but it can run into, in niche scenarios, it can run into issues like if you're doing certain game art things that I'll show you in my next example, where you're like sharing UV space among objects, and you're like, not baking, exactly the same things, or you're mirroring stuff. Yeah, I'll definitely show you examples of where bounds mode fails, but when bounds mode does fail, you can resort to the more manual origin mode and still have a lot easier time doing it than renaming stuff manually, right? So it's going to be more of a manual process, but it's still automatic in a lot of ways. You just have to have some user intervention, and use some of these tools here to manually set origins, but they'll be automatically matched after you've done that. Yep. So that's pretty much a general overview of how to get going with this. You also have some troubleshooting utilities here and like a reset selection thing. This will just reset the name of your object. So if I hit reset here, you'll see it resets it back to standard numbering without the suffix. That can be useful if you're just trying to like clean slate all your objects. You can just reset them, or you can like change the name here to like cube. You can reset all your names to like cube there and start from scratch. You can also do detect conflicts, and I'll show you a quick example of detect conflicts. This is only for low polys, and it's really, it runs, see, auto detect conflicts runs before the matching, and find unmatched runs after. So you can detect if there's going to be any conflicting low polys beforehand, and you can also find any objects that failed to match afterwards. So I'll go ahead and hide all my high polys here, and just as an example here, I'll go ahead and duplicate one, so we have one in the same spot, and then I'll set my low polys here, and they'll have unique names now, but two of them are going to be in the same spot. So now I can hit detect conflicts, and out of all of these, it will find those two conflicting ones because they're in the same spot. And this, you can also adjust this to be bounds or origin. It also works based on those. Same with find unmatched. It'll work on either bounds or origin. So if I do detect conflicts here, it'll work. I'll show you an example here. If I move the mesh out of here, it still has the same origin point. So this, it'll detect the conflict on origin, but it won't on bounds. I'll show you that now. So I'll detect conflicts, no conflict on here, because the bounds are outside. But if I switch to origin mode, you'll see they conflict now because it's going based on the origin now. So that's just sort of how that works. So for an example of like unmatched, I guess I'll turn the high polys back on. I'll select one of these, duplicate it out, move it out here so that it doesn't have anything to go with. And then I'll just go ahead and match again. I think we're ready to go. I'll set these as my low poly. Set it to object again because I changed the cube. Yep, like so. And then we'll go ahead and match visible. Okay, so you'll see down here in this readout, this is the terminal window, by the way. You can get to this in window toggle system console is the not the terminal, it's the system console. So it'll give you a readout here of objects that get matched, whether it's a high poly or like floating geometry here. And it'll also give you the utility information. So there are no conflicts, but there are unmatched objects because we have one here that's loose. It doesn't have a low poly to go with. And this will work for low polys too. If I have a low poly that's not matched here, I'll go ahead and I'll set this as low poly. Here, let me just reset my low polys here. Low poly, okay. So now if I go ahead and, yep, so you'll see for the low poly, it's found as unmatched too, down here, because this one doesn't have a high poly to go with. So that is unmatched. And these objects here don't have a low poly to go with, so they're unmatched as well. So it will automatically kind of tell you the problems that there are, if they're, and if you can ignore them if you know, as I'll show you later, if you know that they are supposed to be like that, you can totally ignore them, but you can also turn these off and they won't run, and it'll just make the calculation a little faster. It won't have to go through and do this. You can also run these manually too. You don't need to auto do them. So there's a lot of flexibility in how you use this. If you know that there are going to be no issues, you can turn these off to save time. You can also run them manually if you want to check stuff afterwards or get selections back or whatever for resolving unmatched objects and all of that. Yeah, so that's pretty much how to use BakeMatcher. I think I've gone over everything. Up next here, I will go over a practical real-world example to show you exactly how you would go about doing this in practice. And yeah, see you soon. Alright, so now that we've gone over how to use BakeMatcher, let's tackle a practical example with this howitzer here. Now this howitzer has around 272 objects for the high poly at least. The low poly might vary slightly. And I've got this organized into a few collections, mainly just for the barrel and for some of the mirrored stuff. I will go ahead and hide the low poly just so we can see. Yeah, we just got like a barrel, an animated section of the barrel has its own collection on the low poly. Main one, mirrored stuff. And on the low poly, I've got, yeah, here's the animated one. I just got some animated parts and like the whole barrel assembly, and got the mirrored parts here. Alright, so start off for matching, I'm going to go ahead and select the low collection, and I'm going to go and select all the objects in it. And you can see here, we've got some hidden stuff, but we won't worry about that. That's just for some shared UV stuff that I did, but that's not important for baking or any of that. So now I've got all my objects selected here for the low poly, and I'll go ahead and just verify that they're all, yep, they are. And I'll go ahead and set these objects as my low poly, and you'll see it won't affect the hidden stuff. It'll just affect whatever's visible, all the stuff we want to set, and you'll see there's 268 objects on our low poly, and that'll be fine. Alright, so now I will go ahead and turn the high poly on so you can see it. And then I'll do a bounds match by visible because I want to do everything and I want to start off with bounds. Then we'll go through and we will correct any problems and we'll match any remaining ones with origin mode. I'm going to leave the auto detect conflicts and auto find unmatch turned on so you can see if there are any issues when we match. So I'm going to go ahead and hit match, and it'll just take a second to start working. And when it does start working, we'll see, yep, there we go, on the left side over here, chugging along, matching all the different objects that it can. And at the end of this, we'll see that we're probably going to end up with some unmatched objects. And I'll show you why that is in a second here and how to, yep, so we'll see. We got some objects here that haven't been matched together, and they'll be automatically selected. So I'm going to go ahead and isolate these, and we'll see that not all of the objects have been matched with bounds, but most of them have. So it's really just about, and you can see all these objects have something in common, and that's they are using shared UVs, or rather, there's only one object that gets baked, and then they get duplicated a couple times. And that's something done to save on UV space. So to fix this, we're going to end up doing a origin match, but before we do that, you'll see we're going to have to set all of our origin points to our objects first. And the way I like to do that is by setting the high poly origin point to the low poly origin point. So I'm going to go ahead and hide all my high poly objects here. I'm going to select all of my low poly objects, and I'm going to do origin to bounds. And you'll see all the origin points get set to the bounds of my objects here. And then we can start matching the high polys to them. So I'll just go ahead and go through them pretty much at random. I'm going to select the high poly object, then I'm going to shift select the low poly object, and I'll see my origin point here. And I'm going to use origin to active, and that's going to set the origin point of my high poly object to my low poly object. So I'm just going to go ahead and go through and do this for all my objects here. Now that I've gone ahead and done some of them, what I'm going to do is I'm going to find unmatched on, or rather I will go ahead and match our visible based on origin here. And it will automatically match some of those. And you'll see we have a smaller list of unmatched objects now, so we can go a step further and isolate these now. And then we can just finish up on these and sort of narrow things down a bit. Okay, I'm going to go ahead and do another match, and we'll see what we're left with. Okay. Here. Okay, we got one here. All right. Got one here. Go ahead and look, see what's going on with this one. Tab out of all of these. Okay, what do we got here? What's going on? Okay. Gotta match that one. And I'll just go ahead and set that. Okay. We'll find unmatched. Isolate. We'll match visible. And these two should be matched now. Yep, they are. Now we're just left with these. So these ones don't have a low poly object, and you'll sort of know because I had 268 low poly objects in it and 272 high polys. These I set up to use shared UVs for, and so I'll just show you an example of what I mean. So this one here gets copied over to here. So this one isn't actually baking. It's only here to bake for like AO, ambient occlusion, and curvature, whatever I have to bake, so that this surface gets the data from this high poly baked onto it. That one actually doesn't bake to a low poly otherwise, not for normal data anyway. So, and that's the same case for these bolt type features there. So now all of our objects have been matched, and we can just do final checks if we want. We can find unmatched on everything, and we'll see we still have our same objects here. So just the ones that we set up for shared UVs, these ones won't have matches, and that's totally fine. So the rest of these are matched, and we can just go through and look at them just to see. You'll see that this is object 1, and these are correct. You can just check a couple more. This is 67, and these are matched. This one is 57, and these are matched. So all of these objects have been matched correctly to their appropriate corresponding model in 3D space. And that is a lot quicker and a lot more efficient than going through here and naming them one by one, trying to figure out which objects are which, or combining them into sets and trying to make sure that the sets contain the same objects. It just saves a lot of time and a lot of headache. And you have some really cool, troubleshooting utilities to make the process even easier for you. So yeah, that's how you would go about actually doing it on a real a real example, a real use case here. And I hope that you're able to save a lot of time as I have using this plugin. So, all right, that's all, and take care.